Imagine you're looking down from a plane, and you see a river snaking across the landscape. Its curves are so dramatic, they look like someone idly doodled on a map. You might wonder, why don't rivers just run straight? Wouldn't that be faster and more efficient? This seemingly simple question hides one of the most fascinating secrets in geology and fluid dynamics. This isn't just about water, it's a story about laziness, time, and an endless dance between erosion and deposition. Prepare to dive into a world where water chooses the path of least resistance, and the result is anything but simple. The truth is, a river is, by geological definition, incredibly lazy. Water always chooses the easiest way out. The moment a river encounters a spot, even slightly softer or lower on one bank, it takes that turn, no questions asked. This slight deviation leaves a tiny mark, a bit of bank erosion here, a little sediment buildup there. Over a human lifetime, these small shifts are invisible, but accumulated over decades, even centuries, they compound into those beautiful, winding S-curves we see from above. This phenomenon is scientifically called meandering, and it's the signature of a persistent, yet fundamentally lazy flow. The secret weapon behind meandering is a perpetual, two-sided process: erosion and deposition. A river doesn't just pass through land, it subtly reshapes the terrain as it goes. Think of every river bend as a negotiation with the land. On the outside of the curve, the cut bank, the water flows faster and stronger. This increased velocity causes the water's erosive power to spike. Every drop of water, carrying tiny grains of sediment, acts like a microscopic file, constantly grinding away at the bank. Conversely, on the inside of the curve, the point bar, the water slows down. Here, the sand and silt it was carrying drop out of suspension and accumulate. This is deposition. This push and pull, cutting away on one side, building up on the other, is how the river constantly repaints its own landscape. Why not build a straight canal then? Why does nature insist on the curve? Because in a straight channel, the water flows so fast that it creates turbulence, which causes massive, uniform erosion on both banks. It's an unstable situation. The curve, however, provides a self-regulating stability. It balances the fast, cutting flow with the slow, building flow. It's the river's way of finding the most efficient, long-term, and stable path. When a river hits a flat floodplain, a wide, open space, it's like a car hitting an open highway. Where the land is steep or rocky, the water rushes too fast to meander. But when it reaches that wide, flat plain, the river begins to stroll, taking its sweet time, winding left and right. Sometimes, a river gets a little too ambitious with its curving. As the meanders grow more exaggerated, the river's path becomes longer and longer. All it takes then is one major flood or an intense period of erosion. The water, fed up with the long route, decides to take the shortcut. It cuts directly across the narrow neck of land, separating the two ends of an extreme meander. The old, curved section is sealed off from the main flow by accumulated silt and is left behind, forming a serene, U-shaped body of water. This is known as an oxbow lake. Think of the mighty Amazon River, where you can find hundreds of these oxbows. Each one is a river's time capsule, a quiet testament to its historical journey. The river's curvy nature is not just a geological oddity, it's a biological paradise. The meandering creates a stunning diversity of flow conditions. One side of the curve has fast, deep water and a steep bank. The other side has slow, shallow water and a gentle slope. This variation in depth, speed, and habitat creates countless micro-environments. The curve ensures that a single river stretch supports maximum biodiversity. Where the water is fast and deep, fish can swim and hunt. Where it is slow and shallow, wading birds find ideal feeding grounds. The point bars become safe nurseries for eggs and small fry. The river's winding path is nature's deliberate stroke of design. Historically, human civilization has always followed the curve. The floodplains created by meandering rivers, like the Nile or the Thames, are some of the most fertile lands on Earth. While they frequently flood, this natural process is a delivery service for nutrient-rich sediment or alluvium. Ancient people chose to settle along these winding rivers, not for the view, but because it guaranteed the essentials for a healthy, abundant life. The oxbow lakes and the meanders themselves formed natural shelters and hunting grounds. Essentially, the curves of the river dictated where and how civilization could flourish. For centuries, humanity has intervened, trying to fix the river's winding path. We straighten rivers, a process called channelization, to make shipping faster, farming more convenient, and ostensibly, to control flooding. But every time we force a river into a straitjacket, the river rebels. When water is forced into a straight, narrow channel, it accelerates. This faster, more powerful flow increases erosion dramatically and destroys habitats. Ironically, straightening a river can lead to more destructive floods downstream because the water moves too quickly. Today, scientists and engineers are actively encouraging the restoration of natural meanders. A curved river is a stable, sustainable, and environmentally superior river. The meanders we see today are not modern creations. Many of the sweeping curves began forming during or right after the last ice age. Geologists can even find fossilized rivers. Ancient channels turn to rock that still clearly show their original winding paths. But here is where the story truly expands. Scientists have found evidence of meandering channels on Mars. Yes, the red planet once had winding rivers, suggesting that the basic laws of fluid dynamics, gravity, and geology are universal. Every time you look down, you aren't just seeing a river. You're looking at planetary history. It is history written in sediment and sculpted by the patient hand of time. So, rivers don't curve to annoy cartographers. They curve because it is the path of least long-term resistance, the most stable, energy-efficient, and life-supporting way to flow. The meander is a perfect geological mechanism that creates fertile floodplains and supports vast ecosystems. What is the most interesting thing you have ever learned about a natural process that seems simple, but is actually incredibly complex? Drop your thoughts in the comments below. We read every single one, and your idea might be the focus of our next deep dive video. If you enjoyed uncovering this secret of the natural world, please subscribe for more fascinating science and mystery. And don't forget to hit the notification bell so you don't miss our next video!